Okay, so this is going to be a quick tutorial on how you can use your periodic table to help you do quantum numbers. So first things first, there's 4 quantum numbers. The first quantum number is what energy level your electron's in. So if you take a look down the numbers on the side, 1 through 7, 3, 4, 5, 6, 4 and 5, and 2, 3, 4, 5, 6. Make note that your helium, even though it's way over here, is still part of your first energy level. So if I put my finger on, let's say, carbon, I'd be like, well, the first quantum number is 2. If I put my finger on deuterium, I'd say the first quantum number is 4. If I put my finger on uranium, I'd say the first quantum number is 5. And when I say uranium, what I mean is the 93rd electron, the last electron in each of these particular orbitals. So the second quantum number tells us the shape. So the shape of the orbital is either going to be S, P, D, or F. And if we take a look at our periodic table, this is our S block, this is our P block, this is our D block, and this is our F block down here. Each of these corresponds to a number. 0 corresponds to S, D corresponds to 2, and P corresponds to 1, and F corresponds to 3. What that means is this, is I can put my finger now on any electron, let's say the 11th electron, and I can say that the first quantum number is 3, and the second quantum number is 0. Or I could say the first quantum number for phosphorus, the 15th electron, is 3, and since it's in a p orbital, the second quantum number is 1. But the thing that the periodic table really shines at is it also can help us with the third and the fourth quantum number. Now, if you are having trouble understanding what each of these quantum numbers are, I encourage you to go back and look at the previous videos that talked about that, particularly the intro to quantum numbers. But here's what's really cool. Since p orbitals come in a set of 3, the way we number the p orbitals, we go 0 in the middle, and we go -1, and we go 1. So if we're actually putting electrons into orbitals, we go -1, 0, 1, and then go back again and go -1, 0, 1. So on the periodic table itself, we can write this as -1, 0, 1, -1, 0, and 1. Make sure this applies only for this column right here. And that means that everything in this column right here, the third quantum number is -1. Everything in this column is 0. Everything in this column it's 1, -1, etc. So if I were to ask you, what are the 3 quantum numbers for phosphorus? I could say the first quantum number is 3. It's in a p orbital, which means that the second quantum number is 1. And then if I look over at it, it's in the 1 category, and so the third quantum number would be a 1. The d orbital works exactly the same way, except the d orbital, there are 5 orbitals that we're putting electrons in, and we go -2, -1, 0, 1, and 2, and then we go back and go -2, -1, 0, 1, 2. So when we're putting electrons in here, we're going to go -2, -1, 0, 1, 2, and then -2, -1, 0, 1, 2. Similarly, we now know the 3 quantum numbers for any of the elements in the D block. So for example, if I said zinc, I'd go zinc is in the third energy level, so its first quantum number is 3. It's in a d orbital, so its second quantum number is 2. And it's in the 2 column, so its third quantum number is a 2. The F block, similarly, there's 7 orbitals. I'm not going to show you with on my fingers, and they go -3, -2, -1 all the way across. So we're going to go -3, -2, -1, 0, 1, 2, 3. And now we have all of the third quantum numbers for the F block. Again, do an example of this. If I said uranium and I asked for the first 3 quantum numbers for uranium, I'd go first quantum number is 5. The second quantum number is 3 because that's what an F shape is. And the third quantum number would be a -1. So both these things in here are -1. Lastly, we love the S block because the third quantum number for both columns always is 0. So the first quantum number is based on what the row is, but then the second and the third quantum number is always going to be a 0. So if I said rubidium, I can immediately go 5, 0, 0, because the shape is a 0, and the third quantum number, which orbital it's in, is also 0 because there's only 1 orbital for S. Lastly, and this is super cool, the fourth quantum number tells you whether or not you're the first or second electron in an orbital. Now, again, refer back to the previous videos to figure out what that actually means. But on the periodic table, it's really neat because if you take a look at your p orbitals, the first 3 are all going to be one electron in, and the second 3 are going to be the second electron in. So if we put a dotted line going up here, or a line, everything on this side, these first 3 columns, are all going to be plus 1/2. Everything on this side is going to be minus 1/2. So that means that right now I could do the 4 quantum numbers for, let's say, carbon, and I would go, first quantum number is 2. The second quantum number is a 1, because p is equal to 1. This is kind of messy here, I apologize. The third quantum number is a 0, and since it's on the plus 1/2 side, the fourth quantum number is a plus 1/2. Similarly, for the D block, if I counted over 5, 1, 2, 3, 4, 5, and put a dotted line up here like this side is plus 1/2, this side is minus 1/2. So if I did, for example, scandium, I could go, the first quantum number is 3, the second quantum number, since the d orbital, is 2, it's a minus 2 for the third, and it's a plus 1/2 for the fourth. The S block is super great because there's only 2 columns here. The first column is plus 1/2. I wrote a minus there. Plus 1/2, and the second column is minus 1/2. So now the example of rubidium, I go, rubidium is 5, and the 2 middle column numbers are always 0. So 0, 0, and then it'd be plus 1/2 for the fourth number. And then down at the very bottom, if you were to go between gadolinium and tiberium, we're going to do it underneath, which is not the greatest. This side is plus 1/2, and this side is minus 1/2. So if I were to do uranium, I'd go, the first quantum number is 5, because it's in the 5th energy level. The shape is a 3 for the second quantum number. It's in a minus 1 orbital, and it's in a plus 1/2. It's the first electron in there, so it's a plus 1/2. So I would encourage you guys to look back at the intro to quantum numbers to get an idea of how the quantum numbers work. But then this periodic table right now, it will allow you, just by writing it up this way, to be able to put your finger on any number of electrons and be able to determine the quantum numbers for that particular electron. Let me remind you again, though, when we say, hey, give me the 4 quantum numbers for chlorine, there are actually 17 electrons in chlorine, and each one of those 17 electrons will have a unique set of 4 quantum numbers. That's called the Pauli exclusion principle. When I say give me the 4 quantum numbers for chlorine, what I really mean is give me the 4 quantum numbers for the 17th electron in chlorine, and only that electron. So hopefully this has been helpful, and this will help you do well on your test. Thanks a lot. Bye.